All right, we're going to do practice 5A, problems 1 through 6. So we're doing work and work at an angle. So let's look at number 2. So whenever we do a problem, again, we're going to write our given and we're going to write our find. And we're going to chunk when we read the problem, because if we read it all at once, we might see too much information. So it says how much work. So here's our given and here's our find. So I want to find the work, because it says how much is done in lifting a 60 kilogram crate. So the mass is 60 kilograms, a vertical distance of 10 meters. So remember, work is only done in the direction in which an object moves. So if I have a crate and it's on the ground and I'm lifting it up, the force that's being displaced there is the force of weight, because the weight is a force that acts down and it's being displaced, whatever this d is. So first we have to find the weight. So F of g is mg, so it's 60 kilograms times 9.8 meters per second squared. So the weight comes out to be 588 newtons. Now when I find the work, we know that work is equal to FD. So in this case, it's the force of weight times that vertical distance. So it's 588 newtons times 10 meters, and then that comes out to be 5880 joules, because a newton times a meter is a joule. So the key there is work is done in the direction the object moves. So what force is in the vertical direction? The weight. All right, let's look at number 6. So it says it takes, so again for number 6, we're going to write our given and we're going to write our find. So it says it takes 1.2 times 10 to the 4 joules of work, so that's W, to pull a loaded sled weighing, so now that's the weight of the sled, a distance of 2 times 10 to the 2 meters. To do this, an applied force is exerted on a rope. So remember, a push or a pull is an applied force which makes an angle with the horizontal. What is the angle on the rope? So I want to find theta. So if I conceptualize this, I have the ground and I have this sled that's being pulled with an angle. Now remember, we did free body diagrams. This is my applied force. My weight acts down like this. Now which direction is the sled moving? The sled is moving this way. Okay? So what's doing the work here? What's doing the work is the component of the applied force. So if you remember, this is where I start. I'm going to go horizontal. So this would be FA horizontal. From the head of this vector, I do the tail of the other. This would be FA vertical. So the only component that's going in the direction it moves is this horizontal component of the applied force. Because it's adjacent to the given angle, that's going to be cosine. So the work done, work is equal to FD cosine theta, but remember we want to solve for theta. So I'm going to rearrange the equation to solve for the unknown or in terms of the known. So I want theta by itself. So I'll divide by FD. So I'll have W over FD is equal to cosine theta. At this point, I would substitute in my values. So cosine theta is W, 1.2 times 10 to the 4 divided by 1.20 times 10 to the 2 newtons times 2 times 10 to the 2 meters. All right. And remember, a newton times a meter is a joule, so my units cancel. So I'm just going to get but this is going to give me cosine theta. So when I do that on my calculator, cosine theta comes out to be 0.5, but I don't want cosine theta, I want theta. So when I press second or inverse on my calculator, cosine to the -1, I end up with theta is equal to 60 degrees. So the point of this problem is that sometimes they give you more forces that you don't need to solve the problem because work is only done in the direction in which the object moves, and in this case, the object is moving in the horizontal direction.